What makes great teams great and poor teams poor? What are the real differences between world-class software development and the rest? There are a few things that I can think of, but one technique underpins them all and shapes everything else. If you're aiming to improve your organization, it is this one thing that is the difference between success and failure. So that's our topic for today. Hello, I'm Dave Farley and welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content, hit like and talk to us in the comments as well. Thanks. According to research from Bain & Company, quoted in a recent book by my friend Dave Clack, 88% of business transformation efforts fall short of their aims. When you get results like that, that's not a statistical quirk. That means that whatever it is that you're doing is simply not working. The failure is understandable, but so common that it is pretty much the norm, as we can see from the 88% number. The failure is in seeing this destination as the only target, and so attempting to make this change as one big step. Success or failure is measured by arriving at the predefined destination defined from the outset. But in reality, it's a lot more complex than that. In fact, it's literally complex. And I describe what I mean by that in this video where I talk about Dave Snowden's Cynefin, a decision-making system and sense-making model for categorizing systems and defining how to make progress in each different type of system. Understanding the nature of the system that you are working in is essential, particularly at the most complex end of the spectrum, that is, in complex adaptive systems. This is essential to be able to make good progress. I nearly said good predictable progress there, but that's the whole point really, because in a complex adaptive system, there is no predictability. That's what makes them complex. Complex adaptive systems are different in important ways that mean that if we attempt to treat them as though they were simple, predictable systems, our chances of success are literally, in reality, random. The identifying characteristics of such systems is that cause and effect can only be seen in hindsight, and the system shifts constantly as you interact with it. For systems like these, a fixed plan of execution is worse than useless really, because as soon as you take the first step in your plan, the system as a whole will change in an unpredictable way. So the assumptions that your plan is built on will have changed. This means that everything else that you planned after that first step is now probably wrong. Let's pause there and say thanks to our sponsors. This channel would not be possible without the support and sponsorship of Equal Experts, Transfig, Octopus Deploy, and our Patreon community. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. All of these companies, though, offer products and services that are extremely well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering in general, why not click on the links in the description below and check them out. So when we're working within a complex adaptive system, the only really sane approach is to probe, sense, and respond through a series of safe-to-fail experiments. Organizations in general, certainly large organizations, and organizations building software in particular, are complex adaptive systems in their own right. For example, what will happen if you ask developer A and developer B to implement exactly the same feature? Will you get exactly the same result? Of course not. Never precisely the same, even for very, very simple changes. But even in general terms, will the code become easier to change or more difficult after each developer has made their change? There's no way of knowing even this. It could be either. It could be better or it could be worse. What will happen if you delete a test? Maybe nothing at all. Maybe we'll leak a bad bug into production. Or maybe the build will run faster and everyone's work will speed up as a result, and the company will make more money. What happens if a developer decides to move on to another job? Maybe the project collapses, maybe things go more slowly, or maybe things go faster. No one can know for sure because it depends on so many other things. These are all examples of the unpredictability of complex adaptive systems. The system as a whole can be modified by any change that we choose to make, and we can't reliably predict how any given change will play out. So there's only one really sane response, which is to treat every change, whatever its nature, as a self-contained experiment. We probe, sense, and respond. This is what I mean when I talk about working experimentally. But there's an alternative perspective that may land more effectively when thinking about this and applying it as part of an organizational change. The fundamental reason that we need to adopt this strategy is because we are inside and trying to effect change from within a complex adaptive system. And organizing change as a series of small, controlled, safe experiments is really the only way to controllably, deliberately improve such systems. Applying predictable, repeatable, best practice style thinking does work for simple systems, but misapplying that to a complex adaptive system is a fundamental category error. If you do this, Cynefin says you get literally random results because you're guessing without feedback. And so now you're working in a chaotic system, not even a complex adaptive one, which means that your chances of progress and success end up being essentially random. Working experimentally allows us to make progress in small verifiable steps that tell us if our guesses in the context of the current version of our complex adaptive system make any sense. This is the route to continuous improvement, organized as a series of small, controlled steps. Fundamentally, this strategy is at the roots of ideas like agile development, lean manufacturing, and ultimately science and engineering in general. This is how we make progress when we can't know the answers before we try them. If we try our idea and its impact is bad, we can step back to safety. If we like the results, we can proceed to try our next idea, having made a small improvement. It is this process of continuous improvement that really underpins a scientifically rational approach to problem solving. If you'd like to learn more about how to adopt this kind of approach, we provide training for individuals, teams, and whole organizations. Check out our Engineering Excellence program in the links in the description. And also check out my book of tips and guidelines, the Software Developer's Guidebook. That can also help you. That's also linked in the description below. This idea of continuous improvement is what everyone says that they want, even if the idea of working experimentally makes them feel nervous because they prefer more certainty. This is important because one of the biggest pushbacks that I get when trying to advise organizations on how to do better is that they can't be experimental because they have to get things right. This is once again the same category error. If you try to treat a complex adaptive system as a simple, predictable one, you make it more, not less, chaotic. This is a bad mistake and is one of the most significant barriers to making progress, and probably one of the explanations for that 88% failure rate of organizational transformation. I don't very much like the us and them analysis of technical organizations, very much. Development versus business. Good software development in reality works when different parts of an organization collaborate effectively. As Dave Clack says in his new book, The Case for Connection, technology is not the problem. Technology doesn't fail companies. The relationships between the business and its technology fail companies. The experiment versus certainty clash is exactly one of those places where connection between different parts of an organization is at risk. On the whole, it seems to me that while there may be nuance and misunderstanding when I talk to technical people about working experimentally, I think that by virtue of their training and background, they mostly get this idea. Perhaps better than people from less technical educational backgrounds anyway. But culturally, most organizations seem to be scared of the idea of being experimental in practice. This is usually an organizational systemic problem. People are often rewarded for predictability and punished for being wrong. We have to get it right ends up being a learned survival response. This is not some failure of intellect. The problem is that predictability in a complex adaptive system is simply not an option. So we can't get it right first time. So striving for perfection in this way is always going to end in disappointment, or at least 88% of the time apparently. Having and using an alternative framing, continuous improvement, instead of change as a series of experiments, may help us in these conversations. This may be a useful way of getting to a path that is more likely to succeed. To my mind, continuous improvement and working experimentally are both saying the same thing, but one version may be more palatable to some people. This isn't about being dishonest, it's about communicating effectively, communicating in ways that make our point correctly and more clearly. So what does it take to establish this kind of change in approach within an organisation? Well, it comes down to creating the conditions where experiments are possible, and then the part that people often miss, making that change itself an experiment. First, you have to make it genuinely safe to fail though. Not safe to be careless, that's not what we're looking for, but safe to be wrong when you've tried not to be. If a disproved idea ends up with someone being blamed, then everyone around them learns that lesson really quickly. They will learn to keep their heads down and avoid trying things out, and instead to play it safe, always choosing the more conservative option to protect themselves. The moment people are protecting themselves instead of probing the system, you're back to guessing with no better odds than blind luck. Safety to experiment isn't a nicety here, it's a precondition for everything else. Culturally, safety is mostly based on how leaders behave, not what they say. Second, keep experiments small and reversible. The whole point of safe to fail is that when an idea doesn't work, and plenty won't, we can step back to safety without any harm done. This is where the technical foundations we go on about on this channel all the time really earn their keep. Version control, automated testing, continuous delivery, and so on. The ability to make small change and roll it back in minutes. These aren't just engineering niceties, they make experimenting cheap enough that we can do it all of the time. If every change is expensive and irreversible, of course people are going to be frightened of getting it wrong. The system has made getting it wrong catastrophic. Accepting that failure is always an option, as the Mythbusters used to say, is really a major step in building an experimental culture of continuous improvement. Third, every experiment is built on a guess, and a way to check that guess. A change that has no expected outcome and no way to measure the result isn't an experiment at all, it's just a change. And that's a gamble that you can't learn from. So before you make any change, say what you expect to see, and decide how you'll know when you see it. Then shorten the gap between making the change and seeing the results as far as you possibly can, because the speed of that loop is the speed at which your organisation can learn. This, and making change safe if it fails, are the reasons why we talk about small steps all of the time. And fourth, mind your language. Continuous improvement and a series of experiments are the same idea, but they land very differently with different groups of people. Meet the people where they are, rather than forcing them to come to where you are. You can't install experimental working by decree. You can't write a 12-step plan, set a deadline, and roll it out across the organisation as a big bang. Because that's the exact mistake that we started with. It treats adopting experimentation as a simple, predictable problem, when in reality your organisation is a complex adaptive system. So you have to change the way that you change things. Start with one team, run one real experiment, learn from it in the open, and then let the evidence pull the next step forwards. You adopt continuous improvement by continuously improving. W. Edwards Deming, who spent his life precisely on this, put the stakes about this about as bluntly as anyone ever could. It's not necessary to change because survival is not mandatory. And that's what the 88% are learning the hard way. The businesses that survive and succeed aren't the ones with the best plan, or the ones that predicted the future most accurately. Nobody can do that inside a complex adaptive system. The ones that succeed are the ones that got good at finding things out, the ones that made learning faster and cheaper, and prioritised that over being right first time. I once worked with a very complex organisation. Ironically, this was an organisation that was started by scientists. They built highly complex machines and they worked to a strict multi-year release cadence. As a result, they had a complex, detailed waterfall-style planning and release process. I was, as usual, recommending that they start to move towards keeping their software in an always releasable state, as a way to start them on the path towards working in small, safe steps instead of massive multi-year bet the business releases. They were skeptical and missing the underlying points that I was trying to make. Probably my fault in not explaining myself well enough. But while somebody was explaining their release process, which took months in total, I asked, so what happens if an emergency happens and you have to release the change to fix it? Oh, we can do a Type 7 release in under an hour, they said proudly. So why don't you do all releases as Type 7 releases? I asked, leading the witness. We couldn't possibly do that because the risk is too high. That was the answer that I expected. Their Type 7 release was basically throw all of the safety and precautions built into the development and release processes out of the window, cross your fingers and pray that nothing bad happens. In my experience, organisations working in the chaos domain of conneffing nearly always have the equivalent of this organisation's Type 7 releases. Organisations that embrace continuous improvement quickly reach a point where releasing is so cheap and so fast that they never need a Type 7 release at all. Even in a real emergency, these organisations can move at speed and with the full safety of a regular release. Because when every release is already fast and safe enough, fast and safe stop being a trade-off. So back to where we started. What makes great teams great isn't that they're better at getting things right first time. It's that they've stopped trying to do that. They've accepted that they are working inside a system that no one can fully predict. And they've built good habits, safety, working in small steps, fast feedback, honest measurement, that allow them to learn their way forwards instead of planning their way forwards. That's the one thing that sits underneath all of the others. It's not a process that we install, it's about how we make progress when we can't know the answers in advance. If you take one thing away from this episode, let it be this. Stop asking, how do we get this right? And start asking instead, how do we learn what to do next? Make that your default question, and continuous improvement stops being a poster on the wall and becomes the way that you actually work. Thank you very much for watching. And if you enjoy our stuff on the Modern Software Engineering channel, then please consider us supporting our work by joining our Patreon community. There's links to that in the description below. And finally, thanks to all of our Patreon members for their ongoing support.